Okay, on page 5, we're going to start with item B. So ignore the other items for a moment. Look specifically at item B. So I'll pull this out of the way here for a second. We'll do the go around the room thing. So we'll start with Davis this morning. So you're taking a test. This is exactly the kind of wording you can expect to see on test 4 for item B. So Davis, what would the first thing you would expect me to write?
The interval from 20 to 35.
Point for Davis. So Parker, you're up.
Approximately.
There you go, point for Parker. Then we go to Brooke. Nicely done. Point for Brooke. We got to figure out the 3 subintervals. So Naomi. Okay, so point for Naomi, but the trap they're getting you to step in is you're using the whole table, but the integral only specifies from minute 20 to minute 35. Does that make sense? No worries. Point for Naomi. Zane.
The first one is from 20 to 25.
So what would you have me write on the board?
A bracket from 20 to 25 and 20 to 30.
Point for Zane. Ah, perfect. Mark's just in time.
It's your turn.
That's me.
What are we writing?
Yeah, you can just say pass. Or you can speak. What do we write next?
4.5 times 10.
No. Vicinity, the point, but not correct.
So it would be 2.4 times 5.
There we go.
Oh. Yeah.
And I always want to check the units at least once. So what units should I write, Charlie?
2.4 miles from
And
And the next one would be 2.4.
oh my bad, sorry, I forgot to write the 10.
So those 5, right?
Ah, thank you. So Porter, and then the units would be?
Just miles. So minutes.
And I forgot to pay. So if your calculator is on your desk, I'll give you a ticket. So digging. There we go. See, I'm digging the calculator. Sweet. Ah. Marker.
Oh, sorry. I was not going to like this. I did not was not paying attention. Mark was distracting me. I have my calculator in front.
Ah, there we go.
Sorry, it would never go. I always bring my calculator. I don't have my
Okay. Okay. So, Derek's up. Derek, I want to put a number above this. So what's the result of that multiplication?
That is going to be 7.
What are the units?
7 miles.
Yeah, 7 seems kind of low.
Oh, 12 is 12.
Is it 12?
Yeah. Let's just do that calculation. 12.
Wait for Derek. You're up, Jake.
Then you do plus
Keep going.
2.4 times 5.
Point for Jake. Haley?
Plus 1.3 times 5.
And point for Haley. Questions? You're up, Spencer. What is the 12 miles in purple representing?
That represents the displacement from
You're good.
That represents the displacement from the time interval 20 to 25.
I'll give you 2 for that. That's well said. Like, said it perfectly. Displacement from time 20 to time 25. Questions, anyone? Please.
Wouldn't it be an estimate of the displacement then?
Give you 2 for that. Well done. It is an estimate of the displacement from time 20 to 25. Well said. Question. Awesome. We put it all together. Ty, do you know the final result? No. Okay, grab your, so we've got 12, 12. Do this one for me, Ty. We'll just write it down.
21.5.
What is it? 21.5?
21.5.
And I should have just cheated. You don't have to type it in. 45.5, point for Ty. Okay, questions? Questions, anyone? Please. You're good.
Actual amount displaced be in between the right Riemann sum and the left Riemann sum?
Only if the graph is strictly increasing or strictly decreasing. So because this graph goes up and down, not necessarily. Okay? Hey, quickly, draw what that looks like on your graph. Go, come on. Fast. Go, go, go. Oh, nicely done. Sweet. You did it first, and make sure. You're good. You're fine. Close. So your time is off. Right, the first, like this represents what, Caitlin? Right, so this is their estimate of the displacement from time 20 to 25. So your bar is just in the wrong place. You see how it works? Okay. I'll draw it on the board here. That's kind of hard to check everybody if it takes too long. Okay, look. Here's a good way to mentally make sure you're thinking correctly. You follow Spencer's lead and you say the first time period was 20 to 25, so I've got to have a box there, and the height of that box is 2.4. So that's why I go up to here. So your first box should be from 20 to 25 and should be a height of 2.4. Raise your hand if you have that point. Question. Then we would go to the next subinterval, 20 to 30. That height is the same. And we go from 30 to 35. The height now jumps up to 4.3. If we had been able to calculate the displacement perfectly, we would have been computing an area that would fit in the space I'm now outlining in yellow. So our estimate actually is not that bad,
That's pretty accurate.
because we've got kind of a, one side's helping the other kind of a thing. And they wouldn't really ask whether it's an over or underestimate because it's a little too close. I can ask this though. Raise your hand, please. Is the 12 miles an over or an underestimate? Hand. 12 miles and over or an underestimate? So Spencer?
It looks like an overestimate.
So I did a bad job of explaining it, that's my fault. So from 20 to 25, if we could compute the displacement perfectly, we would be finding the area of rectangles that would be very narrow. So those rectangles would fit like this, like here, and then here. So we would be filling that space with narrow rectangles like that.
Oh, okay.
But our computation only filled this much space. So we're definitely too low. Does that make sense?
Yeah.
Okay. Raise your hand, please, if you knew we had an underestimate point. Questions? Raise your hand, please. From time 25 to 30, do we have is this 12 miles an underestimate or an overestimate? Hands up. There we go. Let's go, Bridger.
Overestimate.
How many agree? Point. Question? Solid. Okay. I need someone to raise their hand and tell me. Actually, let's keep going down the rows here. So we're on Rye. Can you explain in words what that number represents, Ryan?
Displacement.
More detail. You're doing great. Because displacement always has to be with a time period.
From 20 to 35.
Good. So this is the plane's displacement from 20 minutes to 35 minutes. Do your best, Bridger. Say that same thing in different words. Like, what does it mean? All I'm asking you to do is describe to someone who doesn't know what displacement means. It's okay. Let's go to Hayden. You're okay. Point for Hayden, point for Bridger. Tewila, do you have a way of saying what displacement means? Point. Let's go to Cougar. Saying what displacement means.
It is the difference in distance between the start point and the end point.
Super well said. We'll just say difference in position. So difference in position from the start point to the end point. 2 points for Cougar. So I want everyone in the room to raise their hand on this one. In this story right here, based on what you see on this page, do we know where the plane is located at time equal 20? Hands up, come on. Do we know where the plane is located at time equal 20? Just raise your hand if you can answer that yes or no. That's all I want. Just raise your hand if you can say yes or you can say no. Do we know where the plane is located at time equal 20, Jake?
No.
How many agree? Point, we don't. Jake, stay with me. Do we know where the plane is located at time 35? We do not. All we know is that between those two times, the plane has displaced 45.5 to the right, based on our estimate. Questions? Pretty good? Give me 1 to 5 if that feels good. Show me. Solid. Not too bad. Talk to me, dude. Something bothering you. Let it sit for a minute. You're good. 2 points. Anybody else? Please.
So would we be able to more accurately find exactly where either 20, 25, or 30 or 35 would be if you were finding infinitesimally close to each of those?
Good question. I'll see how many people know the answer. So right now we know the plane was somewhere at minute 20. It was somewhere else at minute 35. We know that between those two locations is a 45.5 mile distance. Davis's question is if we make a more accurate integral, so we make the dt very, very small, will we know where the plane is located at time 20 or 35? Hands up. See? Doesn't help. We'd get a better estimate of the displacement, but we still don't know where the plane is at 20 minutes. We don't know where the plane is at 35.
And the reason we don't know that is because we don't know like where it started.
Yeah, the key thing to memorize here, too, for Jacob, is that this formula is not telling you position. It's telling you displacement, and that's it. You don't know where the thing is.
So to find where it starts, we find like at t equals 0, like what the total displacement is at that point, and then add it to that one to see what the, I don't know what I'm saying actually. If
You
we
actually-
find the position at t equals 0, then we know where the starting position is, and then we can go from there.
You're on the right path. I'm going to lead you slightly differently, but you are not wrong at all. Just we need some detail. 2 points for Haley. Okay, so look on your buff packet and notice at the very top there's an equation I think I've referenced before. Right here, I'll pull it down so we can see it. That's the fundamental theorem of calculus. And it says that that integral we performed is equal to this difference in two positions. That difference in two positions, okay? Raise your hand if you know another name for what's inside the green box. It's a name we've been using frequently today. What is the name of the thing inside the green box, Charlie? That's displacement. Point if your hand is raised, 2 for Charlie. Okay, that green box represents displacement. Questions? If you have this or not. Pretty good? Okay, so when you integrate velocity, you are finding displacement, you're not finding position. But look at Haley's idea here. In fact, let's apply Haley's idea to this integral we just did. So I'm going to get rid of this now for a minute. As I frequently will say, if you can understand an idea, you don't have to memorize a formula. It's way better. Like if you're relying on memorizing formulas, it's hard because you get too many formulas in your head. If you memorize ideas, it's much easier. So this integral found the displacement. Raise your hand, please. Let's go back to the goes. So we'll go to Jacob for this one. Jacob, what does this symbol represent in English words?
The position of the plane at time equals 20.
Perfect. Point. So I'm just making this up. I don't know these numbers. I'm just giving as examples. Okay? So just making this up so we can talk about it. Let's pretend we know that S of 20 is equal to, we'll make it simple, we'll say 50. Let's go to Ammon. What units would we assign to 50 miles? Point for Ammon. And if you don't know, Benji, no big deal. You just say, don't know. We just keep talking. We're just trying to get everybody talking. There's a difference between the miles that is expressed in this equation versus the miles that is expressed here. Like this is a different kind of miles. You know the difference between those two miles? Funny.
One of them is.
You're right. Keep going. You did have it. You did. You're good.
It's like. This is an accent, so I don't.
But you're actually on the right page. You're on the right spot. Point for Benji. Look, I really feel like I can sense that you're thinking in exactly the right place. We have an airplane that's flying in a straight path. Let's go to Tessie. How do I represent the 50 on this picture? It's like a location. It's saying, okay, here's the origin of our path. Origin just means location 0. Point for Tessie. If I move along this path to location 50, that's where the plane is at minute 20. So Caitlin, how do I represent this miles on that picture?
Would it just be like the interval?
Nicely done. It's showing it's like a this. I don't know how to do it without my
it's like a
hands.
bracket.
Yeah, it's like a bracket, right? Like we say, okay, here's where the plane is at minute 20, and then this is how we represent the 45.5. 2 points for Caitlin. So that's where Benji was thinking, yes? Yeah, same idea. That I've got a specific location, that's this, a specific position. This is not a position, it's a change in position. Questions? Okay, let's vote. Be honest, if you're voting 1, it's fine, we just gotta know. 1 to 5 on that idea. Most people are good, a couple people still let it kind of settle. If you want to ask them, I don't want to put pressure on you, but if you want to talk about it, just raise your hand and say you don't see it, and we'll try to say it differently. Okay, keep going. Raise your hand if you can tell me the answer to this question. Who knows the answer to that? There we go. It's all about just thinking about what all this stuff means. You're not supposed to be using a formula. You're just supposed to think about what it means. What's S of 35? Which means where is the plane located at minute 35? Keep your hands up. Here's some more hints. At minute 20, the plane is at location 50. Between minute 20 and minute 35, we estimate the plane will displace 45.5 miles further to the right. So raise your hand if you can tell me what goes in that green box. There we go. What goes in the green box? Most everyone's with me. If you still not, Caitlin.
95.5.
Okay, raise your hand if you are confident of the 95.5. 0.2 for Caitlin. If you want to talk about it, please.
Would it be, for the position, would it be approximately 95.5 because we are estimating
It is. The good news on the AP test is they get fairly relaxed about that idea. So you'll see me do the same error, but you are absolutely correct. It is just an approximation of our location. 2 points. Okay. Questions? Okay, here's what we just did as far as the formula. We had the fundamental theorem, which looks like this. The integral from 20 to 35 of v of t dt So what happens is I'm recording the class with this mic, and it's feeding back into the amplification system, and you get that hum. So, electrical engineering. Hey. All right, we're up to Hannah. So you can look at the page, I don't care. According to the fundamental theorem of calculus, what symbols should I write here? Just look at your page number 5 at the top. You should be able to translate what's written there into this situation. can't see it, no big deal. Go
Wouldn't
ahead.
it be S of 35 minus S of 20?
2 points for Hannah. Okay, so this is the fundamental theorem of calculus being applied to the situation we've been discussing. Please.
Why is there an approximation?
Oh, awesome. Hey, look. This is not an approximation. This is absolutely equal. What we've been approximating is this. So we've been approximating the integral, but the fundamental theorem is not an approximation. It's this does equal this. We just have not found a way to find this perfectly.
So the reason that it was an estimation when we were using it before is because we were using the Riemann sum rather than actually doing the instantaneous.
Yeah, so when we have been computing the integral, we've been choosing a dt that is, 5 minutes, not 0.00001
Right.
seconds. So we've been doing an approximation of the integral, but the fundamental theorem is not an approximation. 2 points. Anybody else? Okay, we just figured out, like I told you, that so just looking at your notes, Marin, what did we say this was equal to in our approximation? What did we have? Remember? It's okay. Skip Marin, let's go to Mark. What did we say this was equal to in our approximation?
It was the word, I know what it is.
Just the number.
The number?
Yeah, what number did we come up with?
Oh, 45.5.
There we go. What are the units?
Miles.
Awesome. Point for Mark. Zane, we said that this was what in our little example?
The positions at time equals 1.
Good. What number did we assign?
50 miles.
Nicely done. And then we figured out that this was 95.5. That's the fundamental theorem. Questions? That's it. So that's where Haley was going, I think, like when you're talking, is that if we know one of the positions, like here's 2 different positions, time 20, time 35. If we know one of them, and we can calculate the displacement, we can find the others. But we have to know one of them. So.
Do they usually give one of them?
Yeah, it's very common. It's actually uncommon for them to ask you to calculate just the displacement. It's much more common for them to design a problem where they say, like I did, the position at time 20 is going to be at mile marker 50 miles. And then they say, go find the position at time 35. That's a pretty typical question. And what the packet is trying to talk about in item like A and B is you can rearrange the fundamental theorem to say this: S of 35 must equal S of 20 plus the integral from 20 to 35 of V of t dt. That's an extremely common thing that you will do. Okay? Give me 1 to 5 if creating that equation makes sense to you. Okay, questions? Oh, no, you're just going. Point to the room. Question? Okay, raise your hand if you can tell me. So, look, this is a version of the fundamental theorem. This is a version of the fundamental theorem. Which version you use depends on the question. There's a third version that you can use to find S of 20. I want to write that on the board, so raise your hand, please. How do I write the fundamental theorem so that it says S of 20 equals what goes on the other side of the equal sign? Just do the algebra. You're just rearranging this formula so that we can say S of 20 equals. Hands up, come on. What would the formula say if we write S of 20 equals? That's better. Let's get a couple more. Let's go, Naomi.
S of 35 minus the displacement from 20 to 35.
Nicely done. Point, if you had it, 2 points for Naomi. Okay, so for the rest of the year, critical that you are comfortable with those 3 versions of the fundamental theorem. Questions? Sweet, next thing. Go back to here. We've basically done everything that's on page 5. So go to page 6. Okay, item 6A, we've actually already done that, so we'll skip that one. I had forgotten that this page showed a value for S of 20, so my 50 was incorrect, but it's still the same idea. Item B, though, actually, now we've talked about item B, we'll skip that. We want to go to item C. So here we go, going to go around the room again. So we're on Zane now. So what's the first thing you want me to do, Zane?
So we're looking at the time period from, so yeah, we have read the interval.
Point for Zane.
From 5 to 35.
Let's go to Naomi. Naomi, if I forget to write the integral on my Unit 4 test or the Unit 4 test, how many points do I lose? 3 points from 100. Point for Naomi. Brooke, what do I do next? Tell me what to write.
Start at 5.
Keep going, Brooke. 2 points for Brooke. Well done. Parker, now what?
And then we can do 9.5 times 10.
Let's do an approximate here, but you're good. So 9.5 times 10, we've been checking our units, so we'll skip that for now. Dave, you're up.
4.5 plus 4.5 times 10.
And then Charlotte?
Plus 2.4 times 10.
Nicely done. Questions from anyone? Please.
Do we have to check the units on the written text and then get miles per minute and then minutes?
You don't have to. I recommend it because it does prevent errors, but you don't have to. All you have to do is make sure that when you write this, 2 points for Haley, you will cheat. Look over here, the answer is supposed to be 164. Make sure at that moment, Haley, you do write the word miles and you lose a point. Other questions? Sweet. Item D. Let's go to Porter. What do I write for item D, Porter? Do you know? You're okay. Yeah, I could see if you said wait or you're not sure. Pass, you're good. Derek, what do I do for item D?
You can use the fundamental theorem of calculus to rearrange it so that S at 35
Hold on a second, you're doing great. So S at 35.
equals S of 5 plus the integral, which
Nicely
the
done.
integral is just going to be 164.
Nicely done. And back to Zane's comment, here's where even the AP test writers, like when they're showing you how to do all this stuff, they get very casual with whether it's approximate or equal. So don't stress too much about it. Like, it's important to remember that we are approximating the integral, but they kind of will use the squiggly here, and then they'll kind of forget about it later. So, 2 points for Derek. Any questions? Please, Hayden.
On the AP test, do we have to write the whole of the
Gotcha. So, if you had done this already, like it's on the worksheet here, you would not have to write the integral again. You could just write 164. So, 2 points for Hayden. So raise your hand if you know what goes here. Everyone. Here we go. Let's go, Jake.
203 miles.
200 how many?
203 miles.
2 points for Jake, 1 if you knew it. So, hands up, who knows what kind of miles this represents? What kind of miles is that representing? What kind of miles, Hannah?
where the plane's at time equals 35.
Nicely done. So this is like, I call it a mile marker, a mile, like a position. It's a location where the plane is at time 35. How many knew? 0.2 for Hannah. Questions? Sure, please.
How do you get SM5 again? What is that number?
Right here.
Oh, thank you.
2 points for asking. Okay, we're done with page 6. Go to 7. Done talking about the plane. That's good. Raise your hand if you know the answer to A. Go. Just work it. Raise your hand when you have the answer to A. Please note that in A, you're not supposed to calculate anything. You're just supposed to write an equation. So. We're getting some hands. Here we go. Wait for a few more. So Ty Ember.
I got H of 70.
Hold on a second. Go ahead, Ty.
Is equal to, I don't know how to say it, like, can you go with time times 70?
That's exactly how you say it. Keep going.
BT minus H of 70.
Super close. 2 points for Ty. Just one small error, Bridger.
It'd be plus.
It's plus. So we'd have H of 10, 2 points for Bridger, plus the integral from 10 to 70 v of t dt. Ty, do you see your error?
Yeah.
Okay. Raise your hand if you have that written on your paper. Point. Question. Please.
Since I gave you what H of 10 is, should you still write H of 10 or should you write H of 10?
Oh, awesome question. 2 points. Either way, we're practicing for the written test. I keep telling everyone that this class is all about the equal sign. So because in the description, they declare h of 10 to be a symbol that means 95, you can write either one and you'll get full credit. So you can either write h of 10 here, or you can write 95, either way. For the Alex. Sweet. Let's skip to item C for a second. So let's do C. Let's go back to the around the room thing here. Josh, you're up. What do I do for C?
You draw the intervals with 20.
Perfect. Tell me what to draw.
So you go from 10 to 30, 30 to 50, and 50 to 70.
Point for Josh. Perfect. Let's go to Jake.
When you want to write the interval to start?
Yep. Point for Jake. Let's go to Haley.
When it's approximately 22 times 20.
And here's where I would recommend that, because it's a brand new problem, we check the units just to make sure. So 22 what?
22 miles per minute.
In this case,
Oh, feet per second.
no worries. Keep going, Haley.
Times 20 seconds.
Point for Haley. Spencer, you should calculate if you need to. What number do I want to write above that? I can't do it. No, you can do it in your head.
It's 440
Nicely done. And what are the units, Spencer?
feet.
Point for Spencer. We'll go to Carson. What does the 440 feet represent?
Represents the displacement from time equals 10 to 10 seconds to 20 seconds.
30 in this case. Does that make sense?
Yeah.
Good. Point for Carson. Another way of saying it is the height of the rocket. The height, the rocket was this high as it's flying upward. This is time 10. And then, 20 seconds later, it's climbed 440 more feet.
So you do velocity times time.
Say it again, Josh.
Doesn't matter which way you put that to, like the 22 and 20.
Oh, the order.
Yeah.
It really doesn't. I just follow the integral, since it says velocity multiplied by duration of time.
Okay.
But it doesn't matter. 2 points actually. Questions? Awesome. And you would continue on, so we'll just go quick, finish it off. So let's go to back to Ty Embury.
35 feet per second. Sorry, just 1 second.
And we've checked our units, so I feel okay about not writing them. Rye, you're next.
44 feet per second.
Point for Rye. And we'll cheat, use the answer, so we don't have to spend the time typing it in. We end up with 20 feet. Questions? Item D says estimate the position of the plane at time 70. Please raise your hand if you know what goes in this purple box. And for hands, what goes in the purple box? Keep working, you're doing great. Just looking for a few more hands. There we go. Keep going. Hands, who's got it? There we go. Got everybody now? So Jacob?
Is it 2,100 feet?
2,115?
That's right.
And always remember to put the units, you'll lose points. And you said feet, that was good. 2 points for Jacob. Who else had it? Show me your hands, show me. Point, okay. Questions? Sweet. Draw the picture of what the integral looks like. Go. Stop me if you're unsure. First subinterval goes from 10 to 30. I've got a velocity of 22, so that should look like this. Can you raise your hand if you have that box drawn correctly? Point. Question? Okay, cool. Go to 8. We've done all the talking we need about 8, so we'll skip 8. Next one, go to 9. No idea, Trapezoidal Riemann Sum. It's not hard if you've understood the others. It really isn't. So here we go. It's called a trapezoidal sum because when you draw the picture, you draw trapezoids. So here's what you draw. We're supposed to approximate this integral. So we go over here to the graph. We go from 0 to 20. Like so. Go ahead and draw with me. Okay, instead of drawing a rectangle, we draw a trapezoid. And the way you draw the trapezoid is at time equals 0, the velocity is 5, so that's the height on the left of the trapezoid. At time equal 20, the velocity is 22, so that's the height on the right of the trapezoid. And then you connect the two heights as best you can, like that. Okay? Question? Please.
So would that always make it an exact estimate, or are there still going to be over and under estimates?
2 points for Spencer. You're seeing exactly what I would want you to see, which is because the area we're going to calculate seems to match a lot better than a rectangle, it's a much better estimate, for sure, always. Well, always is a tough word, but I would say generally. However, you still will have an under or over estimate, and here's why. It's hard to see on that picture, so I'm going to draw a more exaggerated picture. If the function I am integrating is concave down. And I create a trapezoid. Don't say it out loud, just raise your hand, please, everyone. Will my trapezoidal Riemann sum be an under or an overestimate? There we go. You can't see it here. So Spencer, which is it?
It's an underestimate.
Underestimate. How many you knew? 0.2%. And then, similarly, if you do a concave up function, now the trapezoidal Riemann sum will be an overestimate. So that's why I had you draw the pictures and we talked about it. Once you can see the pictures, this question of over versus underestimate, I think those are like free AP points because it's not hard to see it. It's not hard to remember. So, anybody else? Awesome. Okay, so that's what trapezoidal looks like on a graph. To compute the trapezoidal sum, that's what we're going to do in C. So let's clear this off and write our integral. 0 to 70 d of t dt is approximately, okay, everyone in the room raise your hand. When we do a right Riemann sum, I'll just say it's dumb. I was trying to come up with a good question. When we do a right Riemann sum, for every subinterval we use one velocity. We're going to do a left Riemann sum, for every subinterval we use one velocity. When we do a midpoint Riemann sum, for every subinterval we use one velocity. However, for a trapezoidal Riemann sum, we use two. 1 to 5, if that makes sense. I like what David is saying. Yep, good. Move on. Okay. Point for voting. Anybody else? Awesome. That's another reason why Spencer correctly noted that the trapezoidal is going to almost always be a better estimate, using more velocities. So what you do is you go to the first subinterval and you write down both velocities. So we have 5, and we also have 22. But we can't take two velocities and multiply by a duration of time. So we average the two velocities, like so. And then we take that average velocity and multiply by the duration of time, which in this case is a time interval of 20 minutes, or 20 seconds, sorry. Questions? Okay, we'll start back on the front. So Cougar, following that pattern, what's the next thing I would write for this particular Riemann sum?
22 plus 29 divided by 2 times 10.
Nicely done. 2 points. You can't see it. Raise your hand. Give a second to process. Jacob, what's the next one?
29 plus 47 divided by 2. Multiplied by 40.
Nicely done. 2 points. And just punch it in your calculator. Turns out to be 2045. Questions? Please.
If we average all the velocities, all would that be like
They won't have you do that for our test, but it makes sense. For sure. Don't forget the units. Points for Emma. Questions? question. Go to number 10. Raise your hand if you know the answer to 10A. Go. Raise your hand if you know the answer to 10A. Waiting here, get more people. There we go. Keep going, a few more, come on. What's the answer to 10A? Let's go, Bridger.
Is it, 5 negative?
Say it louder.
5 and negative 10.
Your thinking is good, but it's somewhere you're thinking different. You said 5 to negative 10. So it says, no, you're okay. Oh, wait a minute. Where are you looking?
I was looking at the graph.
Right here.
Yeah.
That's okay. So where on the graph are you looking, Bridger?
I was looking when it was decreasing.
Oh, gotcha. No worries. Not a bad thought. What you forgot from some time ago, we haven't really talked about this for a while, is 2 points for Bridger. Hands up. What is the indication as to which, like, how do you know which way the particle's moving? Like, what rule must you have memorized, Ty Smith?
No, when it's positive, it's moving right, when it's negative, it's moving left.
Very good. Positive velocity moving right, negative velocity moving left. How many knew? 0.2 for Ty. So, hands up again. What's the answer to A? Let's go, Hayden.
14 to 37.5.
Nicely done. And it's just an estimate, so like my answer in the back said 13.5, but 14 is just as good, because you're just estimating. So the particle's moving left from time equal 13.5 to 37.5 seconds. Raise your hand if you knew. 0.2 per day. We want to talk about it. Please, Josh.
So, because we can't just see exactly that. What if we put like 13 to 37? Would that be fine?
Yeah, totally fine. What will happen on test 4 is because you're allowed to use your calculator, you'll actually pick up your calculator and you'll use the 0 calculating ability to precisely identify the times. And that way there's no question.
And then t equals 13.5 is the same as like 13.5 seconds to 37.5 seconds. So
Say it one more time.
Because you wrote t equals 13.5 to 37.5 seconds, so you could also write both of them in seconds or both of them in t equals, correct?
Tell me what you want me to write it. I think you're fine.
T equals 13.5 to t equals 37.5.
I'm not understanding. It's my bad.
That's okay. So a time equals, so t equals 13.5.
Like you want to write 13 like this?
No, I'm just changing to 37. So t equal to 37. T equals 37.
Oh yeah, that's right. My bad. Sorry. Yes, yes. My bad. Now I get it.
You just wrote it.
You're totally fine. Totally fine. 2 points. Anybody else? You know all the rest of it. Go to 11. Hands up. Tell me the answer to item 11A. What is the answer to item 11A? There we go. Wait for a few more. The answer to item 11A. Hands again for someone who's got it. Go Porter.
Is it like time equals A?
So you're looking here, and no worries, but here's the error. I'll get you to see it for yourself. Right here is the velocity, positive or negative. Good. So it's,
Yeah, I see.
you good? No worries, 2 points for Porter. Hands up, what's the answer to A? 11A. Parker?
Time equals 13.5 and 37.5.
There we go. When the velocity is 0, the particle is at rest. Okay, show me your hands if you knew it. 0.2 for Parker. Question? Sweet. Let's see if there's anything else we need to talk about. Go to 12. Yeah, a lot of words. Okay. We turned the page, Caleb's like, wow. Okay, the graph we've been looking at for velocity shows both positive and negative velocities. Therefore, the particle is moving both left and right. If we were to calculate this area precisely, right here, that area would represent the displacement of the particle to the right. But then if we calculate this area precisely, we would be calculating the displacement of the particle to the left, and we would be getting a negative number. Therefore, if we want to know the total distance traveled, we actually have to add them without any negatives. We can't, it's like this example. So I'm not going to count, you have to count. Here we go. This is one step. Oh, don't count out loud, just count your head. Okay, raise your hand, please. What's my displacement in that example? What's my displacement in that example? Carson?
2.
How many agree? 0.2 for Carson. Raise your hands, please. What is my total distance traveled? What is my total distance traveled, Brooke? How many agree? Point. So when I'm doing total distance traveled, you can't use negatives. When I did displacement, you use negatives. So this is the formula for total distance traveled. You simply make sure that all your velocities are positive. Please.
For the written test, when we're writing out the equation, you just write like 10 times 12 and you write the
I
absolute.
can't hear it. Say it again.
When we're writing the equation for this problem, do we have to write 10 times 12 or the absolute value of negative 10 times 12 for the written?
Outstanding question. I know the answer for the test. I'm more thinking like what's going to help best prevent errors. I think you're fine to just write 10. Yeah. 2 points for Haley. So let's go back to the second row. We'll start with Mark. So we write the integral, of course. I write approximate. Then what do I write, Mark?
You write, okay, so write 10 times.
Very good. I'm going to write absolute value just to emphasize what we really did.
Negative
So we take the absolute value, negative 10. Keep going.
10 times by 12.
So Mark correctly went to the very first subinterval. We're supposed to do a right Riemann sum. Pick the value on the right, found the absolute value, multiplied by 12. 2 points for Mark. So, Zane,
And then you take the absolute value of -8.
I will check. That is correct. 2 points for Zane. Naomi?
Then you're gonna take -4, but then you want the absolute value of that. And then that'd be 7, then you just find it by
Nicely done. 2 points for Naomi. And then Brooke?
What's the absolute value of 7 times 8?
2 points for Brooke. Question? Sweet. Go to 13. And you're good. Awesome. Okay, so you're going to finish the buff packet at home. You won't go on Canvas to tell me that you finished the buff packet until January, because I can't put it into Canvas yet because I want to put it on term 3. Please don't wait until January. Just get it done. They don't have anything to do over the break. What's your shirt? Cool.
Like when you say finish, are we doing the ones we see? It wasn't sealed.
Yeah, hey, sorry to be confusing. I told you to go back and do anything in the buff we didn't do together. So we did, more than half of it together. But just go back and do the ones we didn't do. Just to make sure. That's pretty easy assignment. Okay, so one more time. Hey, listen. Look, one more time. So homework, and I'll ask if you finished it when I see you on Tuesday, so I'll pay you extra credit if you finish. The goal is to go finish everything we didn't do together in the buff. I just handed you the pink. We're going to start talking about the pink, but please don't do anything at home on the pink. Okay? So don't do anything at home on the pink. Okay. We spent, stop the video here.